we zoom out yet further, what's the first thing we notice about cartilage? Well, its color. It's deathly white, isn't it? Why is that? Because it essentially has no blood supply. So if it's avascular, how does it get its oxygen and nutrients for normal function? Well, basically, there's two systems that are going on. We have passive diffusion from subchondral bone. So the subchondral bone has a very rich blood supply, and nutrients and oxygen from the blood vessels can diffuse across the tide mark zone into the deeper layer of the cartilage. Unfortunately, what does tend to happen with age is that tide mark zone does start to ossify, and as such, can essentially start to clog up the pores, so to speak, of that tide mark zone, and thereby decrease the amount of diffusion from subchondral bone. The other subsystem that provides nutrition to cartilage is relatable to the exchange of synovial fluid. So let's just consider that for just a few moments. So synovial fluid is this filtrate of blood plasma regulated by the synovium. It's made up of hyaluron as well as lubricin, and its jobs are to reduce the coefficient of friction, and it does that primarily by having a highly viscous structure. But it also has within it a dissolved oxygen as well as nutrients. So the dominant source of cartilage nutrition is actually from synovial fluid transport. Now this comes about secondary, again, to two subsystems, the first of which is totally passive, and it's by osmosis. Remember those bottle brushes and their high osmolar potential? Well, they draw in the fluid content of the synovial fluid into the cartilage itself, and as such then provide oxygen and nutrients. But there's another subsystem, an active subsystem,